Welcome back. Now, after we are done with this package, is an important topic of VHDL is the data types. And for that matter, आप कोई भी language लीजिए, you should know what are the data types supported by that particular language. Now, VHDL has a rich history of data types. Initially, जब VHDL launch हुआ था 73 में, that is the first version of VHDL. We used to work with simple data types like bit vector. Then we used to have certain integers, boolean. Now we're not going to discuss वो सारे data types हम यहाँ पे discuss नहीं करेंगे because we are only interested in that part that we may use in our project. ठीक है? So one of the let's start with simple data types that we may be using in our project. It is the data type integer. Fine. और जो आपका VHDL है it supports integer values from this range from -2 raised power 31 -1 to 2 raised power 31 -1. So this is a huge range. Now whenever we have to define our inputs या आपका signal, if you have to define it as integer, it is always advisable कि आप range specify कीजिए. For example मेरे architecture में if I define a signal a simply as integer and I don't specify the range, then it has to please remember जैसे मैंने कल भी कहा था कि whenever you write any VHDL script, at the back of your mind you have to kind of visualize what will be the hardware perspective of it कि आपका synthesizer इसका hardware कैसे बनाएगा. Now if you specify only this information, signal A is equal to is an integer, फिर आपका जो synthesizer है it has to allocate hardware resources that will cover this entire range. Means 31 bits यहाँ से 31 bits, so it has to kind of allocate a universal bus of 64 bits, which means a lot of hardware resources. तो अपने एप्लीकेशन के हिसाब से यू मस्ट बी यू मस्ट हैव सम आइडिया कि आपके एप्लीकेशन में व्हाट इज़ द रेंज ऑफ इंटीजर्स यू आर यूजिंग. सो अकॉर्डिंगली मेंशन द रेंज एंड द वे वी डू इट इज समथिंग लाइक दिस. Signal, say signal name is A, we define it as a type integer, then we use the keyword range and we specify the range कि कहाँ से कहाँ तक मुझे चाहिए. For example, I need only 0 to 100, so I will specify. इसका फ़ायदा क्या है कि आपका जो सिंथेसाइज़र है इट विल स्पेसिफाई, क्योंकि 100 के लिए यू मीन यू कैन बाइनरी में जो 100 है आई थिंक यू कैन कोड इट यूजिंग 7 bits. So it will reserve a bus of 7 or 8 bits because you are specified the range. So it's always advisable कि whenever you define your signals या for that matter आपके port definitions में if you are define using an integer, always specify the range या value. ठीक है, कभी आप directly value ही दे सकते हैं. For example, you can use signal say x integer and just pass on the value कि इसका value say 3 है. ठीक है, ताकि जो hardware constraint है आपके synthesizer पे that is eased out. Fine. So this is one data type that we may be using, right? And the way we use it is like this. Always specify the range, always just specify the value. ठीक है. Then we have also natural boolean, but we may not be using them. And one important data type that we will be frequently using, वो हम थोड़ा in depth discuss करेंगे. That is obviously std underscore logic. ठीक है, या इसका vector form. And we will be using this a lot. And like I mentioned in the previous video, it is actually a 9-valued logic system. Means once you define a signal, once you define an input as a type std logic vector, it can take 9 different values, right? So वो जो 9 values है, they are this. It can take a value u, which stands for uninitialized. It can take a value of 0, we call it a forcing 0, या hard 0, या strong 0, forcing low. It can take a value of 1, we call it a forcing high. It can take a value of what else, h, that is equivalent to 1, but it is a weak high. So you may consider अगर आपका value 1 है तो it is exactly 5 volts if you are using a 5 volt system. If it is weak high, it may not be exactly 5, it may be 4.1, 4.2, kind of on that logic. उस हिसाब से ये चीज़ें होती है. Then again we have L, which is weak low. If you are defining 0 volt as your strong low, then if it is 0.5, 0.6, we consider this as a weak low. Then we have don't care, वो आपने डिजिटल इलेक्ट्रॉनिक्स में पढ़ा होगा. कितने आ गए, 1 2 3 4 5 6. Then we have X, we call it forcing unknown. Then इसका weak version we have W, weak unknown. Okay, so that makes 1 2 3 4 5 6 7 8. okay, एक रह जाता है. uninitialized, weak unknown, high भी आ गया, don't भी आ, अच्छा Z, हमारा Z रह गया, that is high impedance. Fine. So every time you define your inputs as signals all the time, it can take any of these 9 values. Fine. Uninitialized means you have not given an initial value. अक्सर simulations में ये use होता है. Forcing low means exactly 0. Forcing high means exactly 1. Weak means their weaker versions. Don't care, you know that what is the application of don't care. Depending upon your Boolean function, it may be taken as 0 or 1. Then forcing unknown, you don't know what the data type is, whether it is 0 or 1. Similarly, इसका weak version, then we have the high impedance. So although you should know these because sometimes they ask these things in the via जब आपका project defense होगा. But again, we will be using for our synthesis this. Simulation में sometimes you may have this, and rest of them, just for the sake of understanding, just you should know these things. इसके साथ ही when we define STD and STD logic vector, although these are the industry standards, because VHDL is a commercial language, आपके maximum commercial, many commercial tools, they do accept this, and we will be only using STD logic and STD logic vector. But साथ में ही we have another data type which is a similar one, we call it STDU logic, and इसका vector version STDU logic vector. ठीक है, और जो U है it stands for unresolved. Right? Again, you don't need this, but if you are interested, in fact I would encourage that कि आप थोड़ा ये देख लो what do you mean by and by that logic. ये जो आपका STD logic है, it is resolved logic system, and this one is unresolved. It has something to do with कि अगर आपके दो wires आ रहे हैं, one is at 0, another is 1, if they meet at a point, अगर आपका, if you have defined them as U logic, they won't be resolved. And if you have defined them as STD logic, they will be resolved according to a particular criteria, according to a particular table. Okay? But again, it will lengthen our discussion. Take it as a small assignment. मैं आपके group में I will share the PDF of a book. तो उसमें आप देखिए, try to just for your information. Like I said, from an implementation perspective, when we'll be using, when we'll be coding our functionalities, it won't affect that much. But sometimes they ask these things, तो थोड़ा पता होना चाहिए. So these are the two data types that we will be using frequently. One is integer, and second one is this STD logic. Apart from this, We also have two data types that is supported by a package std underscore logic underscore earth, and they are basically signed and unsigned. तो इसमें भी VHDL में there is a slight you may get confused about this, so मैं थोड़ा clear कर दूँ यहाँ पे. Usually signed and unsigned, these are the things that we associate with integers. -5 means minus is the sign, 5 is the actual value. Now integers हम कैसे define करते हैं अभी हमने देखा. If I have to define a signal, I define it as a, say its name is a, then I define it as integer. Then either I define the range or I give the exact value, say 0 to 10. Now इस लॉजिक के हिसाब से if you are using signed and unsigned data type, उसका declaration भी ऐसा ही होना चाहिए था, because signed and unsigned are the concepts that we associate with integers. But VHDL में signed and unsigned data types, they are actually based on STD logic. इसका रीज़न ये है कि whenever you define them unsigned, क्योंकि you see जो आपका लॉजिक है ना, जो आपका डिजिटल इलेक्ट्रॉनिक्स है, इज़ बेस्ड ऑन बाइनरी, इज़ बेस्ड ऑन बूलियन. सो वी ट्राई आवर लेवल बेस्ट कि जो भी आपके डेटा टाइप्स है वो उस फॉर्म में मिले इसको, ठीक है. सो इन व्हाट आई एम ट्राइंग टू से इज़, अगर आपको डिफ़ाइन करना है साइंड, सो यू विल डिफ़ाइन योर सिग्नल ए एज साइंड या अनसाइंड like this, 7 down to 0. Similarly unsigned अगर define करना है, so this is one thing that you should remember with respect to VHDL, कि although signed and unsigned they are basically related to integers, क्योंकि signed का concept integers में होता है, and integers are defined like this in VHDL, but as a tradition, yeah, it is the way the language has been built. आपके जो signals होंगे, if you have to define them signed or unsigned, they will be, and ये format it kind of resembles your STD logic vector. उसमें भी हम ऐसे ही define करते हैं. So please remember this thing. So तीन चीज़ें हमने यहाँ पे पढ़ी. One is integer, the data type. Second is STD logic and logic vector. That we'll be using frequently. उसमें U logic एक unresolved version है इसका, although it's not a standard. आपका हमारा जो industry standard है, it's logic and logic vector, but you should go through just to see what the difference between the two is. And then we use these unsigned and signed, although they are a part of integers, but the way we declare them in VHDL is like this, STD logic vector. So these are the three data types that we will be frequently using. And this video, next video we will do a small exercise जहाँ पे we will just see what can be the different scenarios in our actual coding.